ahora tenemos a Juliano Neves, de la empresa ITW Welding de Brasil, el cual nos va a presentar la ponencia Mechanical Properties Assessment of Structural Carbon Steel Welding Joints by means of Submerged Arc Welding Process with Single Arc and Double-Arc Tandem-Arc. Por favor, lo recibimos con un fuerte aplauso.
Good afternoon, people. It's a pleasure to stay here to share our experience developed with a customer in Brazil about the submerged arc welding. Okay. This is the title of this work. Okay. The mechanical properties. Oh, excuse me. The mechanical properties assessment of the structural carbon steel welded joints to submerged arc welding process using single arc and Tandem-Arc. As I told you before, the purpose of this work is to compare the toughness of two low carbon steel welded joints by the submerged arc welding process using single arc and Tandem-Arc, in order to highlight the possibility to implement the tandem SEW process in the precise manufacturing, in which the impact requirements are mandatory. Normally, for this type of steel, impact requirement is not mandatory, but in this case, is. Okay? So what could justify the use of this SAW process in the manufacturing? So I could share with you the experience in the presses manufacturing in the thickness of the plates are so high, and more than 100 millimeters, in some cases until more than 300 millimeters. So to increase the productivity is available to use a SAW tandem process. About the materials and methods used in this work, in the procedure was used the ASTM 36 carbon steel as laminated in 50 millimeter of thickness, according to the composition we can see in the specification in the table. This table shows the composition according to the specification, the certification values. Okay. Another material used in this procedure was the a solid wire according AWS A517 specification, classified as a AM12 key in 397 millimeters and a neutral agglomerated flux. Okay, according the composition, according the table, the specification and certification. Okay, so why ASTM 836 was used in this development? Well, this is a main question in this work. According to ASME Section 9 code, the ASTM 836 steel is classified as a P number 1 group 1 material. So even in precise manufacturing, you can talk for me. Why is not using AWS G1.1? The standard requirement is not the project requirement. So they in this customer they use ASME Section 9 code to qualify these welding procedures. This material doesn't specify impact requirements. but this test may be performed on a supplementary basis on the provided item X5. So, in this case, the presses manufacturing is not used specifically this ASTM A36. Is used the AN 10025-2 S235JR steel is normally used. Similar ASTM in the same pin number and group number according ASME code, section 9 code. In this material, according EN standard, the impact requirements are mandatory, and the application needs to achieve minimum 27 joules at 20 degrees Celsius positive, being this value adopted as a acceptance criterion for this development. About the welding tests, were used a tandem tractor equipped with a AC and DC power source. The spacing between the SAW tractor torches was 16 millimeters, and the angle between the torches was between 10 and 15 degrees. For the single arc welding, only a DC system was used, and in Tandem-Arc welding, both systems were used. Because one of the requirements for the customer, we need to compare original procedure we used normally in your manufacturing, or offering another with tandem process to compare the results. A single arc test piece was named PT01, and the Tandem-Arc test was named PT02, because in the rest of the presentation, I will talk for you PT01 and PT02, because it's easier for me. The 75 degrees Celsius of preheating and the 250 degrees Celsius of post-heating were used, okay? I will explain when I will talk about impact requirements why was used a bevel key in this situation, because there is a specific to use this kind of bevel, okay? In PT1, in PT1 was needed 29 passes of welding passes and 15 layers to complete the welding joint. And PT2, 0.2, the number of passes and layers were 12 to compare the same welding joint. In this way, it is possible to see that there is a big difference in the productivity in this situation, in this optimization of process, okay? About the rate deposition achieved in both situations, in PT01 was achieved 689 kilos per hour, and in PT02 1786 kilos per hour. So it's a big difference in productivity. If it were possible to do this work, we have sure that the productivity will be higher. About the welding parameters used, it's possible to see in this table. In PT01 was used a positive DC current in the range of amperage, according is described in this table. The voltage, the contact tip work distance used was between 25 and 30 millimeters, and the welding speed between about 6 and almost 10 millimeters per second. It's possible to see in the PT02 almost the same welding parameters. However, in the slave wire, you use a voltage a little bit lower because the welding characteristics. After welding, the two test pieces were submitted to power weld heat treatment at 8 hours at 600 degrees, tensile test, bend test, micrograph tests, and CHARPY V-no impact test. Even the temperature in this project is 20 degrees Celsius positive. However, we did in 3 different temperatures to show the difference between the heat input. So, what we wait about how the heat input could decrease the characteristics in the welding joint. So, we wait that when you increase the heat input, the no toughness is decreased. About the test, we will see if it is true. So, about the tensile test, we don't have any problems. All the break location was in the base metal, and the results was achieved higher than the minimum that for this material is 400 MPa. About hardness profile, the hardness profile was made according a standard Petrobras N133. According, you can see in this picture, in 3 lines, okay. In 3 lines, we realized that the hardness values is not so high. It totally very similar, independent. So in PT1 you used a heat input so high, but the hardness value is not so different. About the CHARPY test, okay, I would like to tell for you, for example, what was used a key bevel, because here we have 4 regions when was evaluated the impact requirements. In the welding surface, in welding opposite side, heat affected zone in surface, and heat affected zone opposite side. So the first coupon, impact coupon, is located in the welding surface, the blue color. The red color, it is the welding in opposite side, and the heat affected zone was in the straight bevel side of the bevel, because this situation you don't have any influence of weld metal and base metal. The region is very more the requirements in this region. The results is a critical region for impact results, because this was used key bevel. So about the values, in 3 situations, the values were higher than 27 joules. Okay, the minimum to be achieved would be should be more than 27 joules, and in 4 situations that was measured, the impact requirements were so high. In in 20 degrees positive, 0 degrees Celsius, and 20 degrees negative. The lower value achieved was 38 joules in minus 20 degrees Celsius. I would like to talk about the microstructures formed, okay? This is in the welding hood pass microstructure. There you can see the average of the energy impact at positive 20 degrees Celsius. You can see a recrystallized ferritic structure with a little bit iron carbides cemented, okay? Even in this situation, the impact values were so higher than 27 joules. Another area that was measured the impact requirements was in heat-affected zone, okay? When you can see in the left side the base metal steel, and the right side the weld metal. Base metal and weld metal at right. And you can see a circular structure. A circular structure is totally good for impact requirements. So in this case, the impact values absorbed energy was so higher than the minimum that was the 27 joules. And the last micrography was in the weld metal, in the heat-affected zone 2, okay? But in the surface, the last one, this one, it was in the medium of the thickness, and another one in the surface. We can see also a recrystallized, a circular structure, probably tempered martensite, bayonet, ferrite, secondary, and a little bit perlite. Conclusions about this test, okay? After to finish these tests, it is possible to use the SAW Tandem-Arc in ASTM A36 still when there is impact requirements, okay? Based on obtained results, it is possible, according to ASME Section 9 code, to qualify a welding procedure for P1 Group 1 carbon steel using Tandem-Arc process. The toughness values obtained in the CHARPY test suggest that the ductile brittle transition temperature is below than negative 20 degrees Celsius. The obtained structures using SAW single arc and Tandem-Arc welding were similar. We could see that in all the situations were measured, the values were so similar. Didn't have any values so different than expected. Okay, and it's okay. Thank you.
Muy bien, es momento de la ronda de preguntas. ¿Alguien que desea hacer una pregunta? A Juliano.
Yes.
You showed your CHARPY V-notch toughness,
Yes.
and you gave a temperature less than minus 20 degrees.
Yes.
Your weld is a relatively thick weld with a K-joint preparation. Where are you referring to that has that value? Is that an average value?
Let me see. If the temperature was below negative 20 degrees, you asking me?
Yes.
Yes. It suggests that the transition between about, I believe, between 60 degrees Celsius plus or minus 20 degrees.
My point is that you have a thick plate
Yes.
and you have a K-joint.
Yes.
And so at what location did you measure these DBTTs?
So in this case was measured in the surface and the medium, the heat affected zone and the CHARPY test was made in the about a quarter each side.
Right. That's the schematic drawing that you had, right? You had a schematic drawing showing lines.
Yes.
So surface, bottom surface, and then quarter, half, and quarter. Is
Yes.
that the one?
Yes.
Okay. Why would you not have the notch going across down the K, the vertical member of the K? That would have been a more severe case of looking at the toughness of that weld joint.
So if I understand you better, I understand that you ask me if in the higher thickness, the location of CHARPY test, okay? The most I can talk to you that the most the situation, the worst situation to develop a CHARPY test, in my opinion, is the between a quarter to the half of the thickness, because this region is the more influence of the heat input, because let me see, because the tempering effect is higher if I have in the surface, you don't have any the tempering in the surface is not so effect is not so high.
Yeah, I'm more referring to when you have a vertical member here.
Yes.
You would have the overlapping heat affected zone one after another. So if you have any, let's say, catastrophic failure, it would be zipping down that or along the K member in that direction rather than doing it in sections of quarter, half, and 3/4. So you might want to think about it.
So I can research about this question, because I'm not ready to answer in this way. Because because I didn't understand so well because the English, okay, and you can keep in contact with me. I will answer better this question, okay? Okay.
Bueno, agradecemos a Juliano por su ponencia. Tenemos un pequeño receso de 4 minutos para hacer la siguiente ponencia.